And welcome, Calculus 2 students. We are looking into Chapter 9. We're going to be discussing sequences and series. First up are sequences of numbers. A sequence of numbers might be 2, 4, 6, 8, 10, something of that sort. We can write these numbers as an explicit set of elements, or we can write them in a formula in which n begins with 1 and goes on to infinity, meaning that this continues on and on forever. So for A, they want us to write them in this formula, so we're going to write 1 over, and n begins at 1, so it'll be 2 to the first, which is 2, 1 over 2 to the second, which is 4, 1 over 2 to the third, which is 8, and 1 over 2 to the fourth, which is 16, and 1 over 2 to the fifth, which is 32, and I can go do, do, do. And that would be listing out these numbers. They wanted me to list the first 4. I listed the first 5. Sorry about that. And then graphs. So the graph is here. Notice that on this graph, as my n approaches infinity, these numbers continually get smaller and smaller, and they approach 0. So the limit of this series, we could then say, would be equal to 0. So let's look at the next series, or the next sequence. This next list is not quite as straightforward, so we're going to do a little computation here. So if n is 1, I'm going to have negative 1 to the first power times 1 over 1 squared is 1 plus 1, and this would be negative 1/2 for my first one, and we would denote this by saying a sub 1, or of the index 1, is equal to negative 1/2. Let's do a sub 2. That means I will replace my n's with a 2, so negative 1 times negative 1 is positive 1. This would be 2 over 2 squared is 4 plus 1. This would be 2/5. A sub 3, plugging this in, negative 1 to the third is negative 1 times 3 over 9 plus 1. This would be negative 3/10, and if I continue on in this fashion, the fourth term would then be 4 over 17, dot, dot, dot. And now I have listed the first 4 terms. Here's the graph, and on this graph you can see that as n approaches infinity, these numbers are also approaching 0, but they're alternating between the positive and the negative realm of a sub n. In example 2, I'm to do a very similar process to what I just finished with. The example 1, they go ahead and tell me that a sub 1 is equal to 1, and I'm going to use that in order to get a sub 2. So a sub 2 means that, in this case, n equals 1, because 1 plus 1 is 2. So a sub 2 is 2 times a sub 1 plus 1. And a sub 1 is 1, so this would be 2 times 1 plus 1, and this answer would then be 3. A sub 3 happens when n equals 2, so I would get 2 a sub 2 plus 1. This would be 2 times whatever a sub 2 is, and that's 3 plus 1, and this would be 7. I'll continue on. In our next example, they tell me that a sub 1 is negative 1. So a sub 2 is then 2 times a sub 1 plus 1. So I'm going to get 2 times negative 1 plus 1, and this is going to get me negative 1. A sub 3 then is going to be 2 a sub 2 plus 1. And when I plug in that negative 1 again, I'm going to get negative 1. Alright, so this is a sequence where all of the terms are negative 1. So I'll write that up, and there we have it. Okay, so we'll go on to example 3. For our next sequence, in example 3, we are to write the next 2 terms of this sequence. So what I usually do is I try to find the pattern. I look for the pattern in that, am I adding or subtracting the same number all the way to get my next one, or am I multiplying or dividing the same number to get my next one? In this one it appears that I can add 7 to each and I will get my next number. So the next term would then be a 26 following this pattern, and the next one would be a 33. So I have written the next terms of that relationship. Okay, we're to find a recurrence relationship next. So that means I'm going to say a sub 1 is negative 2, and a sub n plus 1 is going to be a sub n plus 7. And that will get me my recurrence relationship. Find an explicit formula. Then this one takes a little bit more work. So let's see what's going on. If I look at a sub 1 equals negative 2, a sub 2 was then negative 2 plus, and let's see, 1 times 7. A sub 3 is negative 2 plus 2 times 7. A sub 4 is negative 2 plus 3 times 7. Now it is for this very reason. Sometimes you'll see textbooks start this one at a sub 0 equals negative 2, and then you would write a sub n plus 1 equals a sub n plus 1, starting where n starts at 0 instead of 1. It really doesn't make any difference either way you do it, but it just makes it easier to look at whenever I go to write the explicit formula. Because on this explicit formula, I'm going to be saying that, let's see, when I look at this one, it's going to be a sub n is going to be 7 times n minus 1 plus negative 2 or minus 2. And if I would have started at 0, I could have just had this as just a plain n. Really doesn't make any difference, but you do have to have a starting spot. So where, I'll just go ahead and say where n equals 1, 2, dot, dot, dot. That's one way to write it. Or you could have written, if you write this out this way, a sub n is 7n minus 2, where n equals 0, 1, 2, dot, dot, dot. Either way you write it, both are correct. Alright, so let's go on to the next one. Our B question. We have to write the next several terms of this sequence. So for 3, 6, 12, 24, 48, I believe they're multiplying by 2 every one down through here. So this next one would be 96 and then 192, dot, dot, dot. Of course, I ran out of room because I'm multiplying by 2 every time. So if I'm going to write this relationship, and let's just go ahead and use a naught equals 3 so that it will look a little prettier, then a sub n plus 1 is 2 times a sub n, and that makes it pretty for n equal then 0, 1, 2, dot, dot, dot. For my explicit formula, I have to figure out what's going on here, and just writing them out really helps me a lot. To write a sub 0 is 3, a sub 1 is 3 times, and then this would be 2, a2 is 3 times, and I guess that would be 4, so that's 2 squared. A sub 3 is 3 times 2 cubed, so I could say that this were the case, and then a sub n equals 3 times 2 to the n, where n is 0, 1, 2. Alright. We're looking at limits of sequences next, and we looked at this A sequence earlier, and we saw that as n goes to infinity, it appears as though this thing is going back and forth, bobbling around that the a sub n equal to 0. So we are going to say that this limit appears to be 0 as far as we can tell. For the B question, now if it doesn't have a limit, we're going to say that it diverges. Here's our definition here. So I'm looking at the limit of this cosine. So really, let me get a graph of this and see what this looks like. By looking at these next two, I would say that because this is not approaching any value whatsoever, I would say that B diverges. And by looking at C, it appears as though this thing is getting bigger and bigger. I can say that this one also diverges because it's not going to a particular value, not going to some unique number L. In example 5, they want us to talk about the limit of this particular sequence. Note that a table was created of values for the first 14 terms, and it seems to me that they are all approaching 4. So if that is the case, we would say that its limit equals 4. In example 6, we're looking at a ball that's being bounced, and its initial bounce was at 20 feet, after which the subsequent bounces are 0.8 times that height. That would mean that I have h sub 0 is 20, h sub 1 is 20 times 0.8, which is the 16. H sub 2 is 16 times the 0.8, which was 12.8. So if I were to write this in a way so that I could have my explicit formula and also my recurrence relation. My recurrence relation, of course, that's the easy one, where h sub 0 is 20, so h sub n plus 1 is just 0.8 times your previous height. So we'll say that h sub n. And in this case, my n begins at 0, 1, 2, ... So there's my recurrence. Now my explicit formula is very similar to the previous example, where I would say that h sub n is equal to my, and I could say it h sub 0 times, so whatever that would mean, whatever height that you dropped it at, times 0.8 to that nth power, and that's very similar to what we did before for that n equals 0, 1, 2. What's the high point after the 10th bounce? I'll probably use this formula. Would be the easiest. So after the 10th bounce, that's going to be 20 times 0.8 to the 10th. What is it after the 20th bounce? That would be 20 times 0.8 to the 20th, and whatever those values are once you crunch them. What's the limit? Looks to me like this ball is eventually going to be at 0 height. So I would say the limit of this sequence is 0. There are times we're going to look at these series of numbers or sequences of numbers, and we're going to find the sum, or what the sum of these numbers might be. If they go to a particular number, we're going to say that that limit converges to that value. If that sum doesn't go to a particular number, we'll say that it diverges. So for the A question, we're supposed to look at this series of number and find the sum of the first one. So I'm just going to say the sum of the first one is just 0.9. The sum of the first two is the 0.9 plus the 0.09, sorry. So that would be 0.99. Sum 3 is 0.999. Sum 4, 0.9999. And then they ask me, where do I think that this sum is going? What would the limit be? I would say that it was going to 1. Alright, I'm looking at the sequence of partial sums here, and I want to find the first 4 terms. So the first one is just the sum from k equals 1 to 1 of 1 over 1 times 1 plus 1. Well, I should put k's in there, and then I'll put the 1 in there. Alright, and now I'll say that this is 1 over 1 times 1 plus 1, and then we'll say this is 1/2. S of 2 is just going to have a 2 up here, so what I will then have is the sum of S1 plus the next one, which would be 1 over 2 times 2 plus 1, and so this would be 1/2 plus 1/6, and adding those I would get 2/3. Doing this again, S of 3 is then S1 plus S2 plus 1 over 3 times 3 plus 1, and I would get the 1/2 plus 1/6 plus 2/3 plus, oh, sorry, I was like, what in the world? I don't write that answer. I could have written S2 plus S3 was what I was wanting to do, but then I decided I was going to write them all. So anyway, that would be 1 over 12, which would then get me 3/4. And if I graph this, they want me to find the first 4, but I think you can get that next one. If I graph this, I get something that looks like this, and you can see that this value is approaching 1. And that is it for this section. Oh, let me share with you their summary. Here's their summary and of everything that we have covered so far. Notice that our integral is a sum, so you can see where we're getting ready to go with this.